All right, so we have a car traveling and it slows down, and we want the impulse. So one thing we need to remember is that, yes, impulse J equals force times time. That's absolutely true. But it also equals the change in momentum. So I'll calculate the change in momentum as 1500 times 35 minus 1500 times 40. And when we put that into our calculations, we'll end up getting 1500 times 5, which is negative 7500 Newton seconds or kilograms meters per second. All right, now here. A 0.25 kilogram ball traveling at a speed of 4 meters per second hits the wall and decompresses to rest over time of 0.5 seconds. What is the force of impact? I wrote some momentum equations down. I wrote that the impulse is force times time. And I think I also wrote that the impulse is mv final minus mv initial, and that's fine. I like to stick these two equations together in problems like this. So we have force times time equals mv final minus mv initial, which is going to be F times 0.5 equals 0.25 times 0 minus 0.25 times the 4 meters per second that we start at. And when we actually work this out, we're going to end up getting F equals negative 2 newtons, but we'll take the absolute value as 2. Number 13, this is actually a conservation of momentum question, so I really want to kind of lay this out. So we have a rifle and a bullet, and both start at rest. So M1, M2, V1 initial, V2 initial, 0, 0. We'll say the rifle is 4 kilograms, and the bullet is about 25 grams. Now, we know that the final speed of the rifle is what we're trying to calculate, and the final speed of the bullet is given as 200 meters per second. Now we can throw in our data. So M1 V1 initial plus M2 V2 initial using the conservation of momentum is going to be M1 V1 final plus M2 V2 final. Awesome. Now as we keep going here, we're going to get 4 times 0 plus 0.025 times 0 equals 4 times our unknown final speed plus 0.025 times 200. So this is going to end up giving us some useful numbers. Let's actually work out this math. I'm going to get 0 here on this left side equals 4VF plus 5. And so when I get VF, VF is going to end up being, when I do this math, 1.25 meters per second. Now, a pendulum has a length of 2.5 meters. What is its period? That's T equals, T equals 2 pi square root of L over G. That's going to be 2 pi. L is 2.5. G is 10. That's going to be 2 pi times the square root of 1 over 4. That's going to equal 2 pi. Whoops. It's going to end up being 2 pi times 2 pi over 2, which is just pi seconds. Number 15, I apologize because frequency is 1 over period. So what we get is that the frequency is going to end up being 1 over pi. That should have been choice E when we do the math, but I didn't quite type that correctly. So that's the last page of the multiple choice. Now we'll move into free response in the next video.